Gauss-Jordan method is one very cool way of finding the inverse of a matrix. Now, if you are still struggling with elementary mathematics, this video is not for you. However, I've still got you covered anyway. Just stay connected with me. Now, to find the inverse of a matrix using Gauss-Jordan method, I'm sure you're familiar with the Identity method already, so I won't be talking about that. Basically, what we want to do here is that we want to kind of transform a matrix A augmented with the identity matrix. We want to transform this matrix to a matrix that looks like this, such that the identity matrix comes to the left, and whatever we are able to produce on the right hand side will be the inverse of the matrix. So this is basically what the Gauss-Jordan method looks like. And how do we achieve this? It's just by performing elementary row operations. We transfer the matrix from here to here. So assume this our matrix here is A. So we can write it as, so we have 4, 3, 2. We have 3, 5, 1. Then we have 2, 1, and 3. So I would augment that with 1, 0, 0, 0, 1, 0, 0, 0, 1. Now, the elementary row operation we would be performing would definitely concern some basic elements like these elements right here. We can have, so we have 3, 2, and we have 3, 1, and we have 2 and 1. So we're going to be going colon after colon. So I'll deal with this colon first, deal with this colon, then move to this last colon. Don't forget, we're trying to make this left-hand side becomes the identity element. We don't really need to bother about the diagonal elements that much, because all we have to do is to turn them to 1 is dividing them by themselves. So we'll do that one as the last step. So how do we convert 3 to 0? How do we convert to 0? And for other colon as well, how do we do this thing? It's just by performing the elementary row operation. And then, like I said earlier, if you are watching this video, and if this video is for you, then you are familiar with how to perform the elementary row operation. However, I'm still going to use this first colon as an example. I will use it to explain how to perform the elementary row operation. So to turn 3 to 0, I need something from the other two rows. And from the other two rows, we have the element 4, and we have the entry 2. These two guys are not in any way a multiple of 3. So therefore, we would have to do something like elimination process. Now, the easiest one to use here is to use 2, combine 2 and 3, so that I can eliminate 3. And how do we do that? If I want to eliminate, all I just need to do is to multiply 3 by 2 and multiply 2 by 3. And once I do that, I'll get 6 and 6, and I can subtract them, and I'll be able to get a 0. Now, to do that now, but it's not only going to be affecting the entries only, it's going to be affecting the entire rows as well. So the first elementary row operation I'm going to be doing is on row 2, and that has to become 2 multiplied by row 2 minus 3 multiplied by row 3. That's settled. And for the third row, I'm going to be having, now we can see that for the third row, there is 2 and there is 4 in row 1. Now, 4 is a multiple of 2, so I can easily say that 2 multiplied by 2 is 4, then 4 minus 4, that would be 0. So that would, since it would affect the entire row, that would be 2 multiplied by row 3 minus the entire row 1. So let's perform this. Now, because nothing is happening to the first row yet, so we can have 4, 3, 2. Then we augment that with 1, 0, 0. Then we have, so now let's perform the operation. Now, if I say 2 multiplied by 3, that's 6. 3 multiplied by 2, that's 6 as well. So 6 minus 6, that gives 0. That one, we know that already. Now, going forward, we have 2 multiplied by 5. 5 is the next element in row 2. So we have 2 multiplied by 5, which is 10. Then 3 multiplied by 1, which is the element in row 3. That would be 3. So we have 10 minus 3, and that would be 7. And moving to the last column, that will be 2 multiplied by 1, which is 2. Then 3 multiplied by 3, that's 9. So we have 2 times 1 is 2, 2 minus 9. That would be negative 7. So we're not done. We have to move to the other side. On the second row here, we have 0, 1, 0. And we have 0, 0, 1 on the third row. So let's go. So we have 2 multiplied by 0. So we have 2 multiplied by 0 minus 3 multiplied by 0. So we know that that's not, that's just going to be 0. And we'll have 2 multiplied by 1 minus 3 multiplied by 0. We also have 2 multiplied by 0 minus 3 multiplied by 1. So that's what we will do in the next line. So we have 2 multiplied by 0, that's 0. Then 2 multiplied by 1 is 2. And since this last element, the one in row 3 is 0, so we just do 2 multiplied by 1, that is a 2. So the next one is 2 multiplied by 0. We have 0 minus 3 multiplied by 1, that's negative 3. So moving to the last stage, we have 2 row 3 minus row 1. So just multiply everything in row 3, we multiply by 2. And we multiply everything in row 1 just by negative 1, and we sum them up together. So 2 times 3 is 4, and 4 minus 4, that would be 0. Then we have 2 times 1, which is 2, then minus 3, that would be a negative 1. And we have 2 times 3 is 6, then 6 minus 2, that would be positive 4. Then we have, on this other side, we have 2 times 0, that will be 0. Then minus 1, that will be negative 1. We have 2 times 0 again, minus 0, so that would just be 0. And lastly, we have 2 times 1, which is 2. Then minus 0, that would be 2 as well. So we have these new matrices that we have produced now. So what is the next agenda is that if you look at the right-hand side, the next zeros that we need to get is the 0 in this first row and the 0 in this third row. We need to convert these two elements to 0. Now, to convert these two elements to 0, what we need to do basically is to turn 3 and 1. But as we can see in this new matrix that we have produced, we have 3 and negative 1 now. So these are the two elements that we need to turn to 0. And how do we do that? We also invoke the elementary row operation. I believe we are getting used to the elementary row operation by now. So to perform this elementary row operation right here, what we need to do is that we need to take note of the fact that these two entries, that is the entries in this place and this place, they are already zeros. And we must ensure that we do not convert them to a non-zero element back. Now, to do that, we have to pay attention to what we are operating on now. Like I said, we are operating on negative 1 and 3 to turn it to 0, which means that we're not touching row 2 at all. So I don't need to bother about this 0. So how do I operate this such that this 0 does not turn to non-zero? So the thing I need to take note is that if I operate this element in row 3, if I operate which is row 1, there is possibility of me getting a non-zero element back here. So it's very, very important to do that. So after you have performed the first elementary row operation, which you can do anyhow you like, you can, do that to get these two zeros. The next elementary row operation you are performing, which is to convert this 3 and negative 1 to 0. The first thing you must take note is that for this first element here, for this first row, you can perform this elementary row operation with anything you like. However, for the third row, it is mandatory that you only perform the elementary row operation with the second row. So that is the thing that you need to take note for the second elementary row operation that you're going to do. That is, you must ensure that the third row is operated with the second row. That is the only way you can keep these two zeros here. So let's go into it. So how do we do that to ensure that we still keep these? The first one, which is 3, which we want to convert to 0, we can use anything that we feel like. First, we can say that let row 1 becomes, so I can say row 1 plus 3 times row 3, because we can see here that we are dealing with 3 and negative 1. So I can operate 3 and negative 1. 3 plus 3 times negative 1, that will be 3 plus negative 3, which will be 0. So I can easily do that for row 1. So that would become row 1 plus 3 times row 3. Yeah. So that's what row 1 will become. And for row 3, I would have this operation. So that would just be, so I have -1 and 7 to deal with. So I have -1 and 7. I told you that it must be these two things. So all I just need to do is to multiply my row 3 with 7 and add it to row 2. That would be 7 times -1, that would be -7 plus 7, that would be 0. So that would be the new operation. So that would be 7 row 3 plus row 2. So let's see what that gives. Row 1 will definitely change. Row 2 is not changing. Row 3 is changing as well. So let's perform the operation. So we have row 1, which is 4, plus 3 times row 3. The element there is 0, so I don't really need to bother that much. That will still be 4 here. Then we have 3, which is the element here. So we have 3 plus 3 times -1. So we already know that will give us 0. Absolutely. So that will be 0. And following the next thing that we need to do here, we have 2 plus 3 times 4. 3 times 4 is 12. And 2 plus that would definitely be 14. So we have 14 here in this place. So we go to the next side. And for the next side, I'm operating this 1 and -1. So I have 1 plus 3 times -1. 3 times -1 is -3. So 1 plus -3, that would be -2. So for this place, I'm definitely going to have -2 like that. So proceeding, we have the next elements there. We have 0 and 0 here. So since we have 0 and 0 in this place, we don't really need to bother that much. It will still be 0. So we have -2 and 0. So proceeding from there, we have the last thing we need to deal with there is 0 and 2. So we have 0, which is the element in row 1. So that's 0 plus 3 times 2, that's 6. So we have 0 plus 6. So that would be equal to 6. So let's put that here. So we are done with row 1. And since row 2 is not going through anything, so we just repeat all the elements there. So we have 0, 7, -7. We have 0, 2, and we have -3. So now to row 3. The row 3 one is going to be easy. Know that this place will still remain 0 based on what we have established. 7 times 0 is 0. 0 plus 0 is still 0. Now 7 times -1, that's -7. Then -7 plus 7, that's 0. This is actually the 0 that we desire to get. Now the next one is 7 multiplied by 4. That is 28. Then 28 plus -7. So that's like 28 minus 7. That's 21. So I'm going to have 21 in this place. So we go to the next side. So for the next side, we have 7 times row 3, which is -1. So that's 7 times -1, that would be -7. The next guy is 0, so we don't need to bother. So this would be a -7. And then the next one is 7 times 0, which will be 0 plus what's in row 2, that's 2. So we have 0 plus 2, which will be equal to 2. And finally, we have 7 times 2, which is 14. Then 14 plus -3, so that's 14 minus 3, and that would be 11. That would be 11. So we have the next thing that we have here. So we have 0, 0 here. We have 0, 0 here. We have 0, 0 here as well. So the next 0, 0 we are dealing with now is 0 here and the 0 here. So how do we get that? We still need to perform the elementary row operation. Now, to perform the elementary row operation on this, I already emphasized the fact that every zeros that we have already gotten before, we have to make sure that they maintain their steeze and composure, such that you don't perform an operation that would in turn now change this 0 to a non-zero element. So the rigidity of this 0 is what we need to first of all consider before we can perform any elementary row. Don't forget, we're turning 14 to 0, we're turning -7 to 0 as well. Now, which means that I have the option of operating row 1 with either of row 2 or row 3. But if I operate row 1 with row 2, the existence of 7 here can easily make this 0 to be a non-zero. So which means that I'm constrained to only operate row 1 with row 3 to do whatever I need to do. So in that situation, I need to operate 14 and 21 and make it to be 0. So, and 14 and 21, they are not direct multiple of each other like that. So what can we do is that we can say 14 is 2 times 7 and 21 is 3 times 7. So we have 3 here, we have 2 here as the different thing that they have. So if I multiply this one by 3 and I multiply this one by 2, they can easily cancel out by just subtracting them. So the elementary row operation that I will do for row 1, so row 1 can become 3 multiplied by row 1 minus 2 multiplied by row 3. And that settles for row 1. Now, the next thing I want to turn to 0 is negative 7. To turn negative 7 to 0, I can operate row 2 with either row 1 or row 3. But we already have 0 at this other end. I don't want this 0 to change. If I don't want this 0 to change, that implies that I cannot operate row 2 with row 1, because with the existence of this 4, I'm going to be getting a non-zero element. So the best thing to use is row 2 and row 3. As you can see, 27 is a multiple of 7. So if I just multiply 3 with negative 7, 21 is a multiple of 7. If I just multiply this negative 7 with 3, then I can easily get 21 and to cancel out. So the row operation we're going to be doing here for our row 2. So row 2 can become 3 multiplied by row 2 plus row 3. And with this, we get what we need. So let's quickly get into that. So for row 1, we have 3 multiplied by 4, which is 3 times 4. That will be 12. Then minus 2 multiplied by 0, so which will be 0 as well. So that will be 12 as the first element in this place. So the next one is 3 multiplied by 0 minus 2 multiplied by 0. So that will still give us a 0. So we have 0 in this place. And for the last stage here, we have 3 multiplied by 14, that's 42. And minus 2 multiplied by 21, that's negative 42. So when the two of them combine, we would also have a 0 here. So moving to the right-hand side, we have 3 multiplied by 6, that's 18. Then negative 2 multiplied by 11, that's negative 22. So we have 18 minus 22, that will be negative 4. So we have negative 4. Sorry, that's for the other side. Sorry about that. I've just skipped something. So let's consider this first case first. 3 multiplied by negative 2, that's negative 6. Then negative 2 multiplied by negative 7, that's positive 14. So we have negative 6 plus 14. That will be 8. So we have 8 here. We would have 8 in this other side. Now, so for the one I was doing earlier, we have 3 times 0, that's 0. Negative 2 times 2, that's negative 4. That implies that negative 4 is going to be here. So we have negative 4 here in this place. And finally, we have 3 times 6, which is 18. Then minus 2 times 11, which is 22. So we have 18 minus 22. That will also be negative 4 in this place as well. So we have that. Then to the second row, we have 3 multiplied by row 2 plus row 3. So that's the operation. So what's the first element here? That's 3 times 0 is 0. 0 plus 0 is also 0. So automatically we have a 0 in this place. Now what follows is we have 3 multiplied by 7. So 3 times row 2, that's 3 multiplied by 7. That's 21. 21 plus row 3, which is 0. So 21 plus 0 is still 21. So I'm going to have 21 in this place. Now, the next one is, of course, we know that that one will be 0 because that's basically what we're trying to turn to 0. 3 times negative 7 is negative 21. The negative 21 plus 21, that would be 0. So 0 would be here as well. So we have 0 in this place. So the next side, we have 3 times 0 is 0. Then plus negative 7, that would just be negative 7. Negative 7. Then we also have 3 times 2, which is 6. 3 times 2 is 6 plus So we are doing 3 times row 2, then plus row 3. So 3 times 2 is 6. Then we have 6 plus 2. That's going to give us 8. 6 plus 2, that will give us 8. Then from here, we have, for the last stage, we have 3 times negative 3. That's going to be negative 9. So negative 9 plus root 3, which is negative 9 plus 11. Negative 9 plus 11, that would be 2. Negative 9 plus 11, that would be 2. So we have 2 in this position. Then for the third row, since we didn't perform any operation on the third row is just going to repeat itself. So we just have 0, 0, 21, negative 7, 2, and 11 in this place. So this is what we're able to produce. Now, for this now, everything is already settled. So basically what we just need to do is to perform the new operation on this is to turn 12 to 1, turn 21 to 1, turn 21 to 1 as well. So all I need to do is to, multiply the entire row 1 with 12, multiply the entire row 2 with 21, and 1 over 12, multiply this one with 1 over 21, and multiply everything here with 1 over 21 as well. And whatever I have left here would be the inverse of this matrix. So let's get into that. So for this now, I will just perform the elementary operation. So row 1 can become 1 over 12 multiplied by row 1. Row 2 can become 1 over 21 multiplied by row 2. And row 3 can become 1 over 21 multiplied by row 3. So if I do that, I'll get 1, 0, 0. Now 8, so that will be 1 over 12 multiplied by 8. And that will definitely be 2 over 3. Negative 4 divided by 12, that will be negative 1 over 3. And since this is negative 4 as well, so that will be negative 1 over 3. Then to the second case, we have 1 over 21 multiplying everything through. This will be 0, 1, 0, definitely. So negative 7 divided by 21, that will be negative 1 over 3. Then we have 8 divided by 21. There's no common factor, so we just add 8 divided by 21. And we have 2 divided by 21, so that will also be 2 divided by 21. And for the third row, we have 0, 0, 1. We're still multiplying through by 1 over 21. So negative 7 divided by 21, that will still be negative 1 over 3. And we have 2 divided by 21. Finally, here we have 11 divided by 21. So indeed, we have been able to produce this matrix now. This matrix we have been able to produce now is identity matrix augmented with the inverse of this matrix. So what is now A inverse? So we can tell that the A inverse, the matrix A inverse, is then going to be 2 over 3, negative 1 over 3, negative 1 over 3. Then we have negative 1 over 3 here. 8 divided by 21, 2 divided by 21, negative 1 over 3, 2 divided by 21, and 11 divided by 20. So this is the Gauss-Jordan method of finding the inverse matrix. Now, this is a very, very interesting one. And like I said, you can use it to pass time anytime you feel like. So if this is not, if you're still struggling with elementary mathematics, this is not for you. Thank you very much for watching. Don't forget to subscribe and follow me. See you in the next one.